Are talking about how you can convert between degrees and radians, which are different types of measurement. So you guys may not know a lot about radians, but I know we've at least seen it in our calculator. Back when we were doing trig functions, we had to make sure our calculator was set in degrees, because if it was in radians, it wasn't giving us the right answer, right? The reason is, when we were solving those problems, we were looking at the degree of the angle, not its radian measure, okay? And you can switch back and forth between the two, but you have to make sure that you have it written correctly for it to convert, okay? So, first of all, degrees. Degrees originated from ancient Babylonians studying stars. Okay. Basically, they were determining the measurement in degrees, maybe between different constellations, things like that, right? And remember, we typically use degrees to measure between some chords or some lines, right? The width that they will open up, right? It might be a small degree or a really large degree. This also measures our arcs, right? It can also be arcs between the stars and the constellations, okay? So, degrees is a unit of measure. Again, tells us how wide or small it is between our chords or our lines, or for the arcs on the circle, again, that's between the chords or the lines. Okay, but then they say, what units are radians in? Well, not really any, because whenever you set up to convert, all of your units are going to eliminate. Okay, so they ask how many radii are on a circle. Okay, well, we know in degrees how many degrees a whole circle is, or how many degrees half of a circle is, right? But we haven't talked about what that looks like in terms of radians. So that would be about 6.28 for 2 pi. Okay, so our radians are going to be measured in units of pi. So they ask in this next little section, how many degrees are in the angles represented below, and then we should look at the fractional pieces of the circle to help us determine that. Okay, so we can see in each one of these circles on the top row here, they have a line drawn through the center, what would look like a radius where it's darkened if you went all the way through a diameter, right? So they're just talking about the top half of the circle. Well, how many degrees is half of a circle? Okay. And in this first problem, they took that 180 and they split it into equal sections. On this first figure, how many pieces did they split the top into? 6. So if I take my 180 and divide it evenly into 6 pieces, I should know how many degrees one section is, right? So what is 180 divided by 6? Okay. So that would mean that one section here, or pi 6 of this circle, is 30 degrees. And I should be able to do that no matter how many sections they split it into, right? So on this next figure, again, they're talking about half of a circle, which is 180, and they split it into how many pieces? So if I divide 180 by 4, we know that one section must be how many degrees? Good. All right. And then on this last one, again, we have 180 degrees. This time it's being split into how many sections? So that piece must be how many degrees? Good. All right. Okay, on this second row here, how many sections do they split the top half into? Okay, so I have 180 being split into 2, which tells us it must be right. Okay, on the next figure, how many pieces do they split the top into? Just one piece, right? So 180 divided by 1, or just 180. Okay? All right, on this last figure, they said they don't just want the top, right? They want the entire circle. Well, how many half circles make up a whole circle? 2. So instead of dividing it, I would need to, right, by 2, which tells us that this should be, very good, which we already knew, right? So everything we just found were the degree equivalent to radians. So all of these were in terms of radians. So apparently an entire circle we know was 360 degrees. Apparently that's equivalent to 2 pi in radians. Okay? 90 degrees is equivalent to pi halves in radians. Okay, so basically, we just kind of figured out how we could convert between the two. So, if we want to convert from degrees to radians, so the answer we got back to what it originally was, all we would need to do is go back and multiply it by pi, right? So we could put pi back into it. And then we would also need to divide our number by that 180, right, that we originally had. Okay, so if you want to convert from degrees to radians, you're going to take your degrees and multiply it by pi over 180. Okay, and if you want to convert from radians to degrees, which is what we were doing up here for these problems, we multiplied it by 180 and divided it by however many sections per pi we had, right? So we'll just use theta to represent our radians. Okay, so you would have your radians times 180 over your units of pi. Okay? So they give us a couple of examples so we can try out these formulas. For part A, in this column, we're converting from degrees to radians, so that's our first formula. My degree is 60. I'm supposed to multiply that by pi over 180. Okay? If it helps, remember you are always welcome to put this term over 1 to keep your line straight, because when we multiply across the top and across the bottom. So in the top, I would have 60 times pi, which would just be over 1 times 180, which is just, and if I type 60 over 180 in my calculator, and convert it back to a fraction, and I should be able to tell that this will simplify to what? 1/3, but remember there would be a pi at the top, so this would be pi thirds. Okay? Alright, I want you guys to try B through E, and in just a second we'll come back and check our answers. On B, my 30 degrees, what did it convert to in radians? Very good. Okay, what about 120? What did it convert to? Good. All right, what did 210 convert to? Very good. All right, and then our last one, 270 converts to 1.5, which is what is a fraction? Good. So we'd have 3 pi over 2. We do need to write these as fractions. Okay. All right. Second column, this time we're converting from radians back to degrees. So that would be this formula. Okay, so theta is representing our radians, what I have right here, and I'm supposed to multiply it by 180 over pi. Okay, so I'm going to multiply across the top and get 180 pi. I'm going to multiply across the bottom and get 6 pi. And what's going to happen to the pi? Right, they're going to divide out. So I could go ahead and cross them out from the beginning and then realize I'm just going to have 180 over 6, which would simplify to, very good. All right, okay. You guys do B, C, D, and we'll check them in just a second. All right, on B, what did pi halves convert to in degrees? Good. And what did C convert to? Good. And D converted to? Very good. All right, so if they ask you to convert from radians to degrees or degrees to radians, you can use these formulas to go back and forth. All right? Okay, if you will flip it over onto the back, it says that we have used proportions before to solve for arc length, right? We also did it for sector area. We have those still up on the board. And they want to know, where did it come from? What was that ratio or proportional you're setting up? So we had this first ratio, which was central angle over 360, right? So it was whatever the angle was for that problem over the entire circle, right? Is equal to arc length, which again is whatever that section is over 2 pi r, the entire circle, okay? So this was our old formula using degrees. We should be able to do the same thing, just instead of having degrees, use radians instead, okay? So it says let's substitute radian information and solve for theta. Okay, well, if I was to change this part right here into our radians, the top would be whatever the radians are for that problem, right? We'll call it theta. Over the entire circle in radians. Well, what did we say a whole circle was in radians? 2 pi. Good. Should be equal to your arc length or your sector area, whatever the formula is. In this case, we are doing arc length. I'm just going to call it S up here in the top. Over the entire circle, which is still 2 pi r. Okay? All right, so this one has that equal sign in the middle, so what we had been doing to solve was cross multiply, right? So if I cross this direction, I would have theta times this 2 pi r is equal to, if we multiply this direction, we have S times 2 pi. Okay? And if we were trying to solve for theta, then we would be trying to get rid of the 2 pi r, right? So that theta would be by itself. So currently we have theta times 2 pi r is equal to S times 2 pi. Okay, well, how could I get rid of the 2 pi r that's currently with theta? What would we do? What? Divide it. All right. It's currently being multiplied by theta, so to get rid of it, we would just divide it. And if we do that to one side, got to do it over here on the other as well. All right, so then your 2's divide out, your pi divides out, and your r divides out, and we are just left with theta over there, right? Okay, over here on this side, my 2's divide out, my pi's divide out. So in the top, we are left with S. In the bottom, we are left with R. Okay, so this is how we could solve for theta. Okay, so then they take this and set it up as our formulas for us to use from here on out to prove that's exactly how it would work. So in the future, anytime that you are trying to find the central angle, this is what we would set up. theta equals S over R, where S is your arc length and R is your radius. Okay, if you're trying to find the arc length, so maybe you already know what theta is, you've already found that it's pi halves or whatever, then you can just plug it in here. These two formulas are the same, right? All they did was say, okay, well, if I want to get S by itself, I would multiply both sides by R, so that would go away. And now this is that formula, right? So they just said it depends on what you're trying to find as to how you're going to set it up. Okay, so again, theta is your central angle, S is your arc length, and R is your radius. So on this first example, they say to find the measure of the intercepted arc. First, they tell us we have to convert from degrees to radians. Okay, so that was our formula from the front page. They told us our degrees is 210. Okay, how could I convert that into radians? What am I supposed to do with my degrees? Times by what? Good. So 210 times pi over 180. Again, remember if you like, you can always put your degree over 1 because we're multiplying across the top and the bottom. So in the top, I have 210 times pi, which is just, right? In the bottom, I have 1 times 180, which is just 180. Okay? And then I can divide 210 by 180 to see that it will simplify to, okay. All right, so we converted our angle from degrees into radians. Okay, now they want us to find arc length. So that would be this formula here. Okay, so we're looking for arc length, which is represented by S. And that would be equal to theta. Well, we just figured out in radians that this is our theta. So we would have 7 pi over 6 times R. Do we know our R? Okay. All right. Again, if it's helpful, you can put that 11 over 1 to keep your line straight. We multiply across the top. I got 7 pi times 11, which is good, over, and 77 not divisible by 6. So here is our arc length. Okay. All right, last example. Our last example says to find the measure of the central angle in radians and degrees. Okay, well first they say to just find the angle because we don't know what it is in radians or degrees right now. Okay, but they did give me the arc length. Right? They said that the arc length is 5 pi over 2. Well, our formula for finding the angle is theta equals S over R. Okay, so we are looking for theta, and this is equal to S. S is the arc length, which they said was 5 pi over 2. Divided by R. What's R? Okay. All right, so I now have a fraction being divided by some other term. So basically, we got a fraction and a fraction right now. Okay, so remember, our rule for this is keep, change, flip. You keep the top part exactly how it is. So I'm going to keep my 5 pi over 2. I change from division right here to multiplication, and I'm going to flip that 5 over. Well, currently this is just 5 or 5 over 1. If I flip that over, it becomes, all right. So now I multiply across the top. 5 pi times 1 is just, and in the bottom 2 times 5 is, and 5 pi over 10 will simplify to, all right. Okay, so here is theta in radians, they want us to now convert this radians into degrees. So how do I convert from radians to degrees? So I should have pi over 2 times 180 over pi. Well, whenever I multiply, what's going to happen to the pi's? Go away. So I've got 180 over 2. Very good. So our theta in radians was pi over 2, but in degrees is 90. Okay.